Welcome back, everyone. Poland is becoming an unexpected force in space innovation, particularly in the area of satellite navigation and payload design. While large space agencies often dominate the headlines, Polish aerospace firms are quietly building specialized systems that support European and global satellite missions. From compact navigation modules to precision positioning tools for Earth observation satellites, Polish engineers are contributing essential components. These are not experimental ideas. They are operational technologies already flying on missions supported by the European Space Agency and commercial providers. Poland is not just launching dreams, it is launching hardware into orbit. Satellite navigation relies on a constellation of satellites orbiting Earth, each continuously broadcasting precise time and position data. Receivers on the ground use signals from at least 4 satellites to calculate their location through a method called trilateration. This process measures the time it takes for each signal to reach the receiver, which translates into distance. By comparing distances from multiple satellites, the receiver pinpoints its position in 3 dimensions. The system must account for atmospheric delays, satellite movement, and relativistic effects, which makes the engineering of both space and ground components extremely precise and technically challenging. Polish aerospace firms design miniature satellite navigation modules that are both accurate and rugged. These modules often include multiple antennas, inertial measurement units, and software algorithms for filtering and smoothing data. The hardware is embedded within spacecraft or payloads where space is limited and conditions are extreme. Engineers must ensure that the unit can resist vibration, temperature variation, and radiation. The algorithms process incoming satellite signals in real time to produce fast and accurate location estimates. The precision of these modules allows them to guide autonomous satellite maneuvers and align instruments with pinpoint accuracy. In terms of payload engineering, Polish companies focus heavily on miniaturization and modular design. A payload is any instrument or device carried by a satellite to perform a specific function, such as imaging data collection or signal relay. The challenge is to pack maximum functionality into the smallest possible mass and volume, while ensuring the unit can survive launch forces and operate in vacuum. Engineers use lightweight composites, advanced circuit integration, and rigorous testing environments to meet these criteria. Each payload must also meet international standards for compatibility with different launch vehicles and satellite platforms. Thermal control is a major factor in payload design. Spacecraft are exposed to both direct sunlight and the deep cold of space, often within short time intervals as they orbit Earth. Polish payloads use a combination of passive and active thermal control systems. Passive systems include multi-layer insulation, thermal coatings, and radiators that dissipate heat. Active systems may involve tiny heaters and thermostats that maintain the internal temperature within operational limits. The engineering behind thermal control is critical because even slight temperature changes can distort optics or degrade electronic performance over time. Another crucial component is the data handling system within each payload. These systems collect, store, and transmit information back to Earth without error. Engineers design custom-printed circuit boards that can endure radiation and electromagnetic interference. They also integrate error correction protocols to protect against bit flips and data corruption during transmission. Polish aerospace teams often build in autonomous diagnostic features that allow the payload to identify and isolate internal problems before they affect mission performance. The ability to process and package data in orbit reduces the burden on ground stations and improves response time. Power management is an area where Polish innovation excels. Space payloads operate on limited energy, typically drawn from solar panels and stored in rechargeable batteries. Efficient power conversion circuits ensure that every milliwatt is used wisely. Engineers design power distribution units that prioritize critical systems and can shut down non-essential components when energy is low. In addition, Polish firms develop algorithms that predict power needs based on mission timing and orbital position. These algorithms help payloads allocate energy to sensors and transmitters only when they are most needed, extending the useful life of each mission. Structural integrity is absolutely essential for all satellite payloads. Launch vehicles subject payloads to really strong vibrations, acoustic forces, and sudden acceleration. Polish engineers conduct extensive simulation and vibration testing to validate their designs before launch. They use computer-aided engineering tools to model stress distribution and test physical models in vacuum chambers. Payloads are mounted using dampers and brackets designed to absorb shock without adding unnecessary weight. The combination of precision design and real-world testing makes sure that the payload will survive the trip to orbit and function correctly once deployed. Communication systems must be perfectly tuned to send and receive data across vast distances. Polish payloads often use radio frequency transceivers designed to operate in specific orbital bands approved by international regulators. Antennas are shaped and positioned to maximize signal strength and reduce interference. Ground stations receive the data, which is then decoded and interpreted. Engineers also work on encryption and signal validation to ensure that only authorized users can access the transmitted data. These communication systems are sometimes equipped with redundancy features, allowing continued operation even if one component fails. Attitude control plays a key role in pointing and stabilizing the payload. In orbit, satellites must keep their instruments aimed precisely to collect usable data. Polish systems use a mix of gyroscopes, magnetometers, and star trackers to determine orientation. Small reaction wheels or magnetorquers adjust the satellite's position without consuming fuel. The software that governs these systems must operate in real time with extremely high accuracy. Attitude control ensures that imaging payloads point correctly at Earth, antennas align with ground stations, and solar panels face the sun. This silent, constant adjustment is what keeps a satellite mission on target. In the near future, Polish aerospace firms may begin designing payloads capable of in-orbit reconfiguration. Instead of launching a payload with fixed functions, these modular systems could adapt their software and hardware settings based on evolving mission needs. For example, a satellite initially used for environmental monitoring could reassign part of its processing power to disaster response imaging after a major event. This would require breakthroughs in flexible architecture, space-grade artificial intelligence, and onboard decision-making. Such adaptive satellites could operate more like multi-purpose platforms rather than single-mission tools, dramatically increasing utility per launch. Another hypothetical direction involves developing autonomous satellite swarms coordinated through Polish navigation modules. Each unit in the swarm would carry lightweight payloads and communicate with neighboring units to share data, avoid collisions, and maintain coordinated coverage of Earth's surface. These swarms could be deployed for wide-area surveillance, agricultural monitoring, or dynamic signal routing. By using peer-to-peer coordination rather than ground control, they could operate with minimal latency and higher fault tolerance. Polish engineers could lead this field by leveraging experience in both modular electronics and distributed control systems to create truly autonomous orbital systems. As Poland continues to invest in aerospace research and collaborate with international partners, its role in the global space industry is expanding quickly. Future Polish payloads may include advanced communication relays, autonomous drone satellite platforms, or instruments for deep space probes. Already, companies based in Warsaw, Krakow, and Rzeszów are winning contracts to supply components for upcoming missions. With a growing talent base and a national strategy for space, Poland is turning small-scale engineering into large-scale impact. Thank you very much for watching. Please like and subscribe.